Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss spontaneity. 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 Okay. Last class I have discussed enthalpy of solution and lattice enthalpy. Now I am going to discuss spontaneity. This term is new for you. Okay, what is this spontaneity? That I will tell you. Okay, this is based on first law of thermodynamics, and extra thing is also involved in it. Then what is spontaneity? Now I am telling you. Actually, it tells about the direction of flow of heat. This spontaneity tells about the direction of flow of heat. Okay, that you keep in mind. Important things I told only in the beginning. Now you try to understand. The first law of thermodynamics tells us about the relationship between the heat absorbed and the work performed on or by a system. It puts no restriction. It puts no restriction on the direction of heat flow. It will not tell. First law of thermodynamics has not put any restriction for the flow of heat. No restriction on the direction of heat flow. However, the flow of heat is unidirectional, means one direction. The flow of heat is unidirectional from higher temperature to lower temperature. In fact, all naturally occurring processes, whether chemical or physical, will tend to proceed spontaneously in one direction only. For example, a gas expanding to fill the available volume. Wherever available volume will be there, gas will flow in that direction. You have to not do anything. Okay, without any, you have to not, from the outside you have to not do. Simply they will, wherever they will see it is the vacant, their gas will flow. This is the example I have given. A gas expanding to fill the available volume. Another example, burning carbon in oxygen. Carbon will burn in oxygen, giving carbon dioxide. You have to not do anything. C plus O2, if it will burn, means if you will supply the heat, it will form CO2. But reverse is not possible. From the carbon dioxide is there, you can't get carbon and oxygen. Correct? And gas I told, they filled. Wherever it was empty, there it filled. But again it can't come back simply by own. That is the things. Here we have to give importance. Okay. But heat will not flow from colder body to warmer body. Okay, here it is important. Reverse is not possible. But heat will not flow from colder body to warmer body on its own. Okay, on its own it will not, from the cold it will not come to the warm by own. On its own it will not come. The gas in the container will not spontaneously contract. Expansion took place, but contraction will not take place simply. The gas in a container will not spontaneously contract into one corner, or carbon dioxide will not form carbon and oxygen spontaneously. These and many other spontaneously occurring changes show unidirectional change. Here we may ask, what is the driving force? Now we may ask, what is the driving force of a spontaneously occurring change? Why it is happening? Due to which force it is happening? Why it is by own it is flowing? Okay, by own it is flowing. Why? Why not reverse? Why not reverse passage? This is the main question. That is the driving force. How it is flowing, correct? Then now we have to understand that things. What determines the direction of a spontaneous change? In this, here we will know all these things. Okay. Then what are the actually? We shall here we will establish some criterion. CRTIERION. Criterion means related to criteria. Criterion. 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 Then here we will know you can say criterion for this process, whether this will take place or not. What are the criteria? Means criterion. Criteria or criterion, that on what basis, on what criteria this process you can say will take place or not. That we will understand here. Let us first understand what do we mean by a spontaneous reaction or change. See, you may think by your common observation that a spontaneous reaction is one which occurs immediately when contact is made between the reactants. Two reactants, when they will touch to each other, means they will made, you can say, contact. That a spontaneous reaction is one which occurs immediately when contact is made between the reactants. Okay, just to take the example of you can say combination of hydrogen and oxygen. Hydrogen and oxygen, H2 plus O2. These gases may be mixed at a room temperature. You can mix it, no problem, and left for many years. Then what you will observe? If you will mix oxygen and hydrogen at a room temperature and left for many years without observing any perceptible change, you will not see any major change. Okay, because it is at room temperature, just simply you have kept both gases, mixed both gases, hydrogen and oxygen. These gases may be mixed at room temperature and left for many years without observing any perceptible change. Not you can say very big change you can observe. Although the reaction is taking place between them. Some reaction, slow reaction will be there, but not the major fast, not the fast. Okay, maybe very slow. The reaction is taking place between them. Okay, then this is called, it is an, but this reaction may be extremely slow slow rate. It is still called, this slow reaction is going on, very slow. Then it is still called a spontaneous reaction because you have not done, maybe reaction very slow, but it is happening. Then this is called a spontaneous reaction. You have not done anything, simply you have mixed both gases, but the reaction was not fast, it was extremely slow, but whatever be, reaction was going on. Then this reaction was going is called spontaneously, means you have not done, then simply you have mixed and reaction takes place by your own. Okay, by your own means spontaneous, you have not done anything. Okay, so spontaneity means, now you can understand, so spontaneity means having the potential to proceed without the assistance of external agency, without external agency. Okay, again you understand that spontaneity means having the potential to proceed without the assistance of external agency. Okay, however it does not tell about the rate of reaction or process. Another aspect of a spontaneous reaction or process, as we see, is that these cannot reverse their direction on their own. They can't reverse the reaction or direction. That is very, very important. Okay, here we will understand these things. Okay, this is very that reaction can't be reversed. No, these cannot reverse their direction on their own. Okay, and so we may summarize, we can summarize the, you can say, a spontaneous reaction. What is a spontaneous reaction? Now we can define like that. A spontaneous process is an irreversible process, only in one direction, unidirection. A spontaneous process is an irreversible process and may only be reversed by some external agency. Without external agency, you can't reverse. This is the, you can say, definition of a spontaneous process. A spontaneous process is an irreversible process and may only be reversed by some external agency. Okay. Then actually important things of this spontaneous process. Now again you can understand what may be the reason. Okay, then what is coming in your mind, maybe due to this, maybe due to this, maybe due to this, then all angle, from each angle you can think. Then in that way you can think enthalpy, heat content, internal energy plus work done, that is the enthalpy. You think for that. You may think that this may be due to the enthalpy, decrease in enthalpy. Okay, then here also you can understand that decrease in enthalpy, you can think that it may be one criteria, decrease in enthalpy. This for a spontaneity, you can think that decrease in enthalpy means energy you are decreasing. Okay, decrease in enthalpy you can think as a criteria for a spontaneity. Maybe or not, that is the things that we are considering. Then you can understand, finally it will be, actually it looks like that maybe criteria, but it will fail in some places. Then I am telling you these things by some example. See, if we examine the phenomena like flow of water from hill or fall of a stone on the ground. Okay, we find that there is a net decrease in potential energy in the direction of change. If we examine the phenomena like flow of water downhill from the hill to down, or fall of a stone onto the ground, we find that there is a net decrease in potential energy in the direction of change. By analogy, we may be tempered to state that a chemical reaction is spontaneous in a given direction because decrease in energy has taken place, as in the case of exothermic reaction. Okay, you can think like that. Example, you know that N2 plus hydrogen means N2 plus H2, 2NH3 it will form, means half N2 plus 3 by 2 H2, or you can write 2N2 plus 3H2 twice NH3. This is the reaction. Then in this reaction, delta H is minus 46.1 kilojoule per mole, exothermic reaction. Okay, that's why you might be thinking that okay, reaction is going outside, means the potential energy is decreasing. Okay, energy is going outside, it means energy is decreasing in this reaction. You can think like that. Other example, H2 plus Cl2, half H2 plus half Cl2 HCl. In this reaction also minus 92.32 kilojoule per mole, delta H is there, delta H, that is the heat of reaction, minus 92.32 kilojoule per mole. Here also heat is going outside. Then you can think, okay, heat is going outside means in this reaction potential energy is decreasing because heat is going outside. Third reaction also you can think that H2 plus half O2, H2O. In this reaction also minus 285.8 kilojoule per mole heat. It is a minus, means exothermic. All three are exothermic reaction. Heat is going outside. It means you may think that in this reaction also potential energy is decreasing. That's why chemical reaction is going on. Okay, it means enthalpy has a role. By seeing this reaction, we can tell that decrease in enthalpy H, that is the reason, because in all three chemical reaction you have seen like this. But this concept will fail. Okay, in this you are thinking like that, but other reaction you can see. Then as for example, NO2 formation, half N2 plus O2, half N2 plus O2, it is forming NO2 gas, and delta H value is now plus 32.2 kilojoule per mole. Okay, plus means endothermic. Now you are giving the energy. Now you are giving the heat to take place this reaction, N2 plus O2, NO2. Then this I told you exothermic and endothermic, but this reaction N2 plus O2, NO2 means, and in the case of endothermic this is also a spontaneous reaction, and other three what I told minus delta H minus, that is also a spontaneous, and this is also a spontaneous. Their heat is going outside, but here you are giving the some heat, then reaction is taking place. Then in both cases actually both are the spontaneous reaction. The decrease in enthalpy in passing from reactants to products may be, you can say, I will tell these things by graph also you can understand. I will tell some reasoning. Okay, thus the you can say driving force for a chemical reaction may be due to the decrease in energy. It looks, it sounds like that it is reasonable as the basis of evidence so far. Now, other example also I am telling you. I have given endothermic reaction. Okay, these reaction, though endothermic, are spontaneous. Means in case of exothermic this exothermic reaction also spontaneous. In this case also spontaneous. In both cases spontaneous. Okay, then how can you tell that this H means enthalpy is a criteria? How can you tell? Okay, because in both these things H is negative, exothermic, endothermic. Okay, in both cases this is the, you can say, spontaneous. Okay, endothermic reaction is also spontaneous, exothermic reactions are also spontaneous. Okay, but here you can tell, I will explain why heat is coming in case of exothermic, why heat is going outside, and in case of endothermic, why you can say heat is absorbed. I will tell you, you can reason for that. Then now, first about the spontaneous, that you think that by seeing all the things, it becomes obvious that while decrease in enthalpy may be contributory factor for spontaneity, but it is not true for all cases. Okay, it is not true for all cases. Now I am telling you why during the reaction, sometimes in case of exothermic reaction, heat is coming out. Sometimes for the reaction, you have to supply the heat, endothermic. Actually, why does it happen? Now, just to understand. Actually, reactants gives the product, correct? Reactant like A plus B, it will react and it will give the product. Then now, actually, if you will think that heat of formation of reactants means A and B, what are the heat? You can say heat of formation for A, heat of formation of B, that you have to first consider. And then what are the heat of formation of products? Suppose C and D is the product. After reacting A plus B, it is giving product C plus D. Then what are the, you can say, heat of formation of reactants? First you add it. And what are the, you can say, heat of products? Okay, heat of formation of products, that also you add it. Then what happens? Suppose heat of products, heat of formation of products, suppose it is more and heat of reactants is less. Okay, it means you want product from the reactants, but there you can say heat of formation of reactants are less, but products requirement is for more heat, but these have less heat. That's why you are supplying heat from the outside, endothermic reaction. Then it will give the product. When both will come, you have supplied the heat. Whatever, actually some heat they will keep, reactant, but that is not sufficient to get the product. Then what are the difference that you have to supply? That is the case of endothermic reaction. That's why that differences of heat you are supplying. That's why plus delta H is plus, you are supplying. And just reverse case, when heat of, you can say, formation of reactant is more and product is less, then what will happen? Extra heat will go out. Heat of formation of reactants are more, but product is less. For the product it required only less. Then extra heat that will go outside. That is the case of exothermic reaction. Correct? You understood why heat is going outside, why heat is coming, heat is required. This is the main reason. Okay. Now I am going to discuss one new terms which you are not knowing. Might be not knowing, particularly 11th student might be not knowing. That is the entropy. Entropy. E-N-T-R-O-P-Y. Entropy. Okay, this is a new term. Then how this entropy and spontaneity are related, that I am going to discuss. Entropy and spontaneity. Okay. Then try to understand entropy. I am telling you, easily you can understand. It is a new term and difficult term to understand, but I think you will understand quickly. Suppose classes are going on, and in class, suppose 60 students are there, all students are sitting in a proper way. Every bench 5 students are sitting. Okay, two rows are there. And okay, in every bench 5 students are sitting. All are sitting in a proper way, classes are going on. Now, as soon as teacher will go from the class, means class is over, then what do you think? All students will be sitting in a proper way? No. They will begin to turn left, right, even some may leave their position also. Then, in the beginning, when they were sitting in a proper way, they were sitting in one order. They were sitting in a proper way, means orderly. Now, after the class, they have disturbed. Some will see back side, someone is the right side, left side, and someone even they can leave their place also. Okay, some may begin to move here and there. Then now you can see this disturbance, what we are telling, disorder. This disorder actually is called entropy. Disorder, chaotic, C-H-O-T-I-C, chaotic, randomness. Then how much disorder took place? As for example, out of 60, suppose 15 students just they have left their place, or they are seeing left, right, back, and other 45 are sitting in a proper way. Correct? Then now only 15 out of 60 are disturbed. Correct? Only 15 students are disturbed, they left their position, are moving here and there, and 45 students are sitting in a proper way. Then this entropy tells about the measurement, how much disorder took place. That is actually entropy. Entropy is the measure of disorderliness. This I have told you very simple way with a general example. Now you can understand that suppose two gases is there, gas A and gas B, and you are keeping two gases in one container having movable, you can say these things, movable partition. Suppose in one container one movable partition is there, then one part gas A you have kept, in other part gas B you have kept. Okay, and then now in one part only gas A is there, other gas B is there, other part. Now we remove the container, this partition. Then what will happen? After some times, after a period of time, if you if you want to remove only gas A or only gas B, then it is not possible, because both gases mixed automatically, spontaneously. You have not done anything, sir. Only you have removed the, you can say, partition. Then they have mixed. They have mixed by diffusion. In diffusion also, no, you are not doing anything, sir. A and B you mix both gases, it will automatically mix. That is called diffusion. You have not done spontaneously. Okay. Then this is the, you can say, case. Now we can understand that gas A and gas B, which was separate, now after removing this partition, they have mixed. Means now they became disordered. Gas A became disordered, gas B also, big molecules of gas A and molecules of gas B became disordered. Understood? Disorder means entropy change took place. If more disorder means more energy, more entropy. Entropy change is more. More disorder means positive entropy. Less disorder means, you can say, negative entropy. Okay, more entropy, more disorder means more entropy. Less disorder means less entropy. This you keep in mind. This is the important things I have told you. Okay, then now I have told about, given the concept of entropy. Then entropy denoted as a S. Again another thing is, it is denoted by capital S. Capital S. Okay. Then how will you define entropy? This is defined as a disorder. The S means entropy. In the you can say the entropy that is telling about the disorder is the manifestation of entropy. Okay, disorder is the manifestation of entropy. To form a mental picture, okay, one can think of entropy as a measure of the degree of randomness or disorder in the system. Okay, the greater the disorder in an isolated system already told you, the greater the disorder in an isolated system means nothing will go, neither will enter, neither energy nor mass will enter or leave. Okay, that is the isolated system. Then greater the disorder in an isolated system, then higher is the entropy. As far as a chemical reaction is concerned, this entropy change can be attributed to rearrangement of atom or ions from one pattern in the reactants to another in the products. In reaction, same things happen there. How will you tell order and disorder? Then reactant, reactant molecules, they have one type of order, but after the reaction they are giving product. Then in product, if you will see all the atoms, they are arranged in a different way. In the reactant they were arranged in one way, and in product same molecules are arranged in another way. Okay, means bond broken, atoms became free, and again they have rearranged and given the product. Okay, then here also disorder took place, means entropy change took place. Then this I have told you in the case of this things, reaction. Okay, that as far as a chemical reaction is concerned, This entropy change can be attributed to rearrangement of atoms or ions from one pattern in the reactants to another in the products. If the structure of the product is very much disorder than that of the reactants, there will be a, you can say, resultant increase in entropy. The change in entropy accompanying a chemical reaction may be estimated qualitatively. We can measure that some change took place by a consideration of, you can say, a structure of the species. By seeing the structure of a species of reactant and product, you can tell that this has gone, means entropy change took place. Okay, then by seeing the structure of the species taking part in the reaction, we can make change, we can understand. Decrease of regularity in a structure, again you try to understand. Decrease of regularity in a structure would mean increase in entropy, reverse way. I am telling you, so many students are not understanding these things. Entropy change means disorder. Entropy increase means disorder. Only one thing you keep in mind. Entropy increased, high, more, means more disorder. Decreased means towards stability. You are going towards stability. Decrease means negative, means stability. Correct? And if it is increasing, then it means instability, disorder. Entropy is increasing. Okay, decreasing means entropy decrease means stability. Increase means instability. Don't forget, this is the concept you should keep in mind while solving the numericals. It will help you too much. Okay. For a given substance, the crystalline solid state is the state of lowest entropy. Lowest entropy means stable. Crystal is stable because their energy will be also less and entropy will be also less. Okay. The crystalline solid state is the state of lowest entropy, most ordered, means most stable. The gaseous state is the state of highest entropy. Highest entropy means more disordered or unstable. I have told about these things. Then qualitatively you have seen qualitatively. Now we think for the quantitatively. How will you measure how much disorder took place? Then two methods are there. Then one is a statistical method, statistics. I told you now that out of 15% a student got, you can say they are moving here and there or left the place. Then this is, you can count, you have counted and then you are telling. But gaseous molecules will be very large number, you can't count simply. Then for that a statistic is applied. That is called statistical thermodynamics. It is beyond your syllabus. Okay, here we can't understand. Only at the master level you can understand. Okay, then another method is there that is related to heat. Then now you can understand if you will apply the heat, then molecules will come in motion. They will begin to move because kinetic energy will increase if you will supply the heat. Okay, which means by supplying the heat you can make the molecules more disturbed, disorder. Then now by the heat molecules are going to be disordered. Means heat has effect on the entropy. Then if you are talking about the heat, then heat must have relation with temperature. If you will give the less temperature, then less disturbance. If you will give the more temperature, if temperature is high, then this also will be high. Correct? Means temperature and heat has relation on entropy. Temperature, heat, okay, temperature, heat and entropy has relation, because Q, heat, has relation on entropy. Then heat is related to temperature. It means all three are related. Okay. Then now these things I have told you that all three are related. Entropy, like any other thermodynamic property, again in new things you understand that entropy, like any other thermodynamic property such as internal energy, that is U, enthalpy, H is a state function, means entropy is also a state function, and delta S is independent of path. Just like other, they are independent of path, already I discussed. This S, delta S is also independent of path, means it depends upon initial and final state. Whenever heat is added to the system, it increases molecular motion, causing increased randomness in the system. Okay, thus heat means Q. Heat means Q. Thus heat has randoming influence. Randoming, okay. Random matlab means it will have effect on randomness. Randomizing influence, you can tell. Randoming influence. Heat has randomizing influence on the system. Okay. Then now again you can see by experience it has been seen. Experience suggests us. It has been seen by experience. Experience, actually full thermodynamics is based on experience. Keep in mind. Full thermodynamics, there are four laws are there. Zeroth law, first law, second law, third law. All law you have to not study it at a lower level. Okay. They are studied higher. First law I am discussing here. Other law you can see just studied at higher level. Then now we require at 11th level of for medical IIT, first law is sufficient. Okay, sometimes second law also I will tell. Then here I am telling you that thermodynamics is based on experience. Okay, then experience suggests us that the distribution of heat also depends on the temperature at which heat is added. Suppose system is at 25 degree and heat you are supplying, and other case you understand when system is 50 degree and heat you are supplying. Two cases you understand. Okay, then what you will feel? That this a system at higher temperature, a system at higher temperature has greater randomness in it than one at lower temperature. Okay, this is the very, very important point I am telling you, that experience suggests us that the distribution of heat also depends upon the temperature at which heat is added to the system. A system at higher temperature has greater randomness in it than one at lower temperature. Very important things. Thus, temperature is the measure of average chaotic motion of particles in the system. Chaotic motion means you are talking about the movement of particles in the system. Heat added to a system at lower temperature, just like a 25 degree, I have told you. Heat added to a system at a lower temperature, when it was the low temperature and you have added the heat, causes greater randomness than when the same quantity of heat, here you understand, same quantity of heat added to it higher temperature. Suppose 50 degree it was there and same quantity of heat added in both cases, then at a less temperature it will have more effect than high temperature. Same heat, same quantity of heat. If you have added at low temperature, it have more effect than same heat when it added at high temperatures, means inversely proportional. Okay. Then here I told you they are very important things, that heat added to a system at lower temperature causes greater randomness than when the same quantity of heat is added to it at higher temperature. This suggests that the entropy change is inversely proportional to the temperature. Then we can write delta S is related with Q and T for a reversible reaction. Reversible reaction already know. You can say this reactant to product and product to reactant will come back, and that situation is called reversibility. Means A to B, again B to A. A to B means reactant to product and product to reactant. That situation, if it is going on continuously, that situation is called reversible reaction. Okay, then here you can get this one, you will get one relation, delta S means change in entropy. That is the, because temperature, that this is a, this entropy change is inversely proportional to temperature. Inversely proportional to temperature. Then you can write that delta S, that is equal to Q reversible divided by T. Heat you are supplying, that is the Q reversible, then delta S is equal to Q reversible REV, you can write reversible shortcut, Q a small q and REV a small REV, you can write down the Q. Then Q reversible divided by T. This is a very, very important formula. I have told you, many numericals you can solve on this formula. When another relation I am telling you, which is very, very important, that is the total entropy change, means delta S of system and delta S for surrounding, means heat, that entropy change of system, just like isolated system, closed system, whatever you can consider system. Then entropy change will be of system also, surrounding also. Then if you will add, I can say this entropy change of system plus entropy change of surrounding, then it is called total change. Total change. Okay, means entropy change total change in entropy, that is a delta S. Down you can write total, a small t, TOTL total. Delta S total is equal to delta S system. SYSTEM system you can write delta S, down you can write system, plus again delta S, down again you write, you can say surrounding, SURR, shortcut you can write delta S surrounding, SURR. Then delta S total, that is equal to delta S system plus delta S surrounding. That this is the total. Then here you should keep in mind, this total will be greater than 0. Greater than 0. This is very, very important relation I am telling you. Then greater than 0 means what? Because due to the disorder, because it is going to be disorder, anyone is going to be disordered. That's why it is not in a orderly, not in a order. Something made a change, took place, little also. Then anyone will be in disorder. Anyone, either system or surrounding. Hence, if you will add both, then it will be greater than 0. This is a very, very important condition to measure the entropy change. Entropy change either of system or surrounding or of the reaction. These are the important things I have told you. When a system is in equilibrium, third important point, always it is asked, all three are asked in examination, all competitive examination, either for medical or engineering, main or advanced. Everywhere it is asked. When a system is in equilibrium, the entropy is maximum, and that time the change in entropy will be 0. Delta S will be 0. That is the third condition. Delta S is equal to 0. Okay. When a system is in equilibrium, the entropy is maximum, and delta S is equal to 0, because the reactant and product both became same, hence change is equal to 0. Okay, entropy change is equal to 0. I have told you 3 relation. Okay, very important. We can say that entropy for a spontaneous process increases till it reaches a maximum. Obviously, that entropy for a spontaneous process increases till it reaches maximum, and at equilibrium the change in entropy is 0. Okay, since entropy is a state property, we can calculate the change in entropy of a reversible process. Same formula, delta S REV, delta S system, S by S, shortcut you can write S by S, delta S system, down you can write S by S, delta S system is equal to Q reversible, Q system, Q S by S system divided by T. Okay, this is the same formula you are writing for only for system, delta S system, that is equal to Q system divided by T. We find that actually already we know that for reversible and irreversible, delta U is equal to 0. We know all the things we have discussed. In case of reversible and in case of irreversible, as expansion, particularly expansion. In case of reversible expansion or irreversible expansion, delta is equal to 0. But here you can see fourth new things you are understanding. Delta S total is not 0. Delta S total means system plus surrounding is not 0. Keep in mind fourth relation, important relation, is not 0 for irreversible. Generally entropy in case of irreversible reaction only. Spontaneous and irreversible both are same. Or natural process, all natural process, falling of anything, waterfall or anything falls from up to down, all are natural process, spontaneous, irreversible, all three have same meaning. Okay, then total, that is the system plus surrounding is not 0. Delta S is not 0 for irreversible process. Thus, delta U does not discriminate between reversible and irreversible, but delta S does. Delta S does discrimination. Okay, this you understand that in case of irreversible expansion, delta S is not 0. Keep in mind. Today I am stopping only here. Next class I will discuss numericals, okay, and some concept. Thank you.